going to continue looking at the law of sine. Now, there's something called the ambiguous case. Well, just like in the world of inequalities, just like in the world of systems, you're going to have times where you have no solutions or a few solutions. So, ambiguous case basically means you could have no true cases, you could have one case, or you could have two solutions, two sets of solutions for solving a missing triangle. In general, if you are given two angles and one side, typically you will have one solution, just like the example I did before. Again, in general, if you are given two sides and one angle, you could have no solutions, one solution, or even two solutions. And you'll basically figure out that that's because an angle could also be obtuse to make the statement true. All right, so let's do an example. Some general facts to remember, okay? The angles inside a triangle, they add up to 180, okay? Another fact to remember is no triangle can have two obtuse angles, because therefore you're going to end up with bigger than 180. And another fact to remember is the fact that your value for sine, so the sine of an angle, that has to be between 1 and -1, okay? So when you type in the sine of an angle, you have to be between 1 and -1 for the statement to hold true. Later on, you'll recognize this when we start to graph the functions. So let's take a look at this example. I have a triangle A, B, C. Angle A is 30 degrees, and I'm given two side lengths. Side A is 7, and side C is 16. So this is where I'm falling into that one case where I'm given two sides and one angle, where it's possible for me to have no solutions, one solution, or two solutions. So I'm using my ratios here. I like my ratio A, okay? So I have sine of 30 all over 7 equals, I don't know my angle C, sine of C all over 16. Now, when I'm solving for an angle, I'm going to have to use sine inverse because I'm going to have to get inside that sine. But I'm first going to do a little bit of cross multiplication. I'm going to bring that 16 out front here. So we have 16 times sine of 30 all over 7. But that didn't completely isolate my variable. I'm still left with sine of angle C. To get inside that sine of C, I'm going to have to take the sine inverse of that side. But I can take a step back. If I type this quantity actually inside my calculator, 16 times sine of 30 all divided by 7, I get 1.14 is equal to sine of C. So before I even took the sine inverse to get C by itself, I recognized that sine was bigger than 1, which is not true. So therefore, there's no solution. Therefore, this triangle does not exist. It is not possible. All right, so I'm going to start you off on an example, just like we did before. This time we're going to end up with two solutions. So I'm given this triangle ABC. Angle A is 30 degrees, side length A is 10, and we're also given side length B is 16. This falls into that category that in general, when you're given two sides and one angle, you could have 0 cases, 1 case, or 2 cases. And as we're actually going to find out, this is going to have 2 cases, 2 possible solutions. So I'm going to solve for my missing pieces here. And I'm going to set up my ratio. I'm going to flip it this time. I'm going to show you that actually it's about the same. That we're going to have side length A is 10, all divided by sine of 30 degrees. Okay? That's going to be equal, let's solve for angle B, because we have the opposite of B, which is 16 side length, and we're doing sine of angle B. Okay, that's what we're solving for. Again, we're going to need to use inverse sine here to help us solve for B. First thing I'm going to do, let's do some cross multiplying. Let's get what we're solving for to the top. So now we have 10 times sine of b is equal to 16 times sine of 30. Next, I'm going to divide everything by 10. So now I have sine of b equals 16 times sine of 30 all over 10. Now, this quantity, as you noticed before, we actually need to check to make sure he's between -1 and 1. And when you type this in, you get 0.8, which is true. So we now know that we have a possibility where we can actually run into having more than one option, okay? So let's solve, and I will go back into how we can find the other option. To get b truly by itself, I actually need to do the sine inverse of both sides, because that is the inverse of sine. So when I take sine inverse of both sides, I'm going to take sine inverse of my quantity 0.8. That will get me that b is approximately 53 degrees. Make sure you are in degree mode. Okay? Now we know we have this possibility that there could be two cases. So let's talk about where you could find your other case. So it's kind of like a fake unit circle here. I know that 53 degrees is approximately right here. All students take calc. So I know that all my values are positive in this quadrant, and I know that my sine values are positive in the second quadrant. 0.8 was my sine value. He is positive, so that I know there is another angle possibility in this quadrant over here. But I just have to figure out what is that angle. Well, it's easy to calculate. We know from 0 to this spot was 53 degrees. This angle is 180 degrees, and the angle arc length is 53 degrees. So 180 minus 53 gets me the fact that this angle is actually 127 degrees. So that is my second possibility for angle B. I could have this be an acute angle, or I could have this be an obtuse angle, and I'm actually going to take a pause. Alright, so now picking up where I left off, I just found out that one of my possibilities for angle B was 53 degrees, and the other possibility was 127. Well, if I'm given two angles of a triangle, I know that they all have to add up to 180, so I could easily calculate what that other angle for C is. So my first possibility, where angle B is 53 degrees, A was 30, I therefore know that 180 minus 30 minus 53 gives me that angle C is approximately 97 degrees. That was one of my situations. He is going to have one set of missing pieces. So you're actually in two sets of solutions. In my other cases, we have that angle B was 127 degrees. So we have 127 degrees, we have a 30 degrees, we all know that it has to add up to 180 degrees, therefore giving me that C is 23 degrees. Okay? These are my multiple cases for angles, but I'm still missing my side length of side C. So I'm going to have to do what I've been doing and solve for that hot spot. You're going to solve as you normally would, and you're going to check and make sure your ratios are all accurate. Okay? Just to prove that my ratios of B and A work, I'm going to point out those solutions. 10 over sine of 30. This is my ratio for A, where his side length and his angle. You type this into your calculator, you get 20. We are going to question whether this is equal to B's ratio. So B's ratio, he had a side length of 16, and he had one possibility of having an angle of 53 degrees. When you type this into your calculator, you get 20.03. Very close, once again, to that first ratio, so we know that it's okay. And just to prove to you that there is the second case, and the ratio does work, we have still our side length of B is 16, and the other angle was sine of 127 degrees. And if you type this into your calculator once again, you get 20.03, close enough. To go forth and finish this problem, you still need to solve for side length C. by plugging it in once again to your ratio, where you can have both of them set equal to your ratio A.